Bonjour à tous.
Hello, everyone. Thank you for coming today to this roundtable around the topic on the SOC in industrial environment. There's three speakers today, high-range speakers. Alain Bellamort from Summer Partners, Mr. Blondel from the Minister of Defense, Monsieur Blanc, sorry, and Mr. Kemisa from Iberis. So we are going to deal with this topic through a number of topics today. And I would like to start with Ms. Delamore. Regarding the SOC, can we say that there are two different types of SOC, an IT SOC or OT SOC? Or should we consider it as being a single SOC? Thank you, Mr. Castaneda, for having organized this roundtable. Thank you for the questions. We are Summer Partner. We are a German company, and we believe in the existence of an IT-OT SOC. There's not two separate ones. There's an IT SOC. We adapted the solutions, the detection solutions, our processes, the piloting processes, the risk analysis, the detection and vulnerability surface risk is adapted to everything that we call the industrial system, but just a separate OT SOC, we don't believe in it. Mr. Blanc, Mr. Commissar, do you want to add something to this? Well, okay, hello everyone, Bertrand Long, I am DSI Cyber at the Ministry of Defense. Just some words on the industrial environments of the Ministry of Defense. We are maybe particular in our use. The Cyber Defense Command is in charge of the protection of and defense of the networks. And we have the three-pillar system, the traditional IT systems, the industrial systems, which I'm going to detail, and the high systems that are more linked to the weapon systems, the embedded weapon systems. On these industrial systems, we have, within the Ministry of Defense, we have the same issues as the ones that we can have in a new generation production site or industrial sites like health or fuel plants, that we have the same particularity in terms of vulnerability. We have a particularity on weapon system. Weapon systems have a digital ecosystem for which we live actually a full revolution, a full transition, since we have systems that, for most of them, have a certain age, a plane, a submarine, a vessel, a ship. Usually when you build a system, you have a fairly long implementation system. At the moment, we're in a full revolution on new programs arriving. So the arrival of these new programs for us has an impact on the supervision modalities, which are completely different from what we have had until now, because when you have a legacy system that is not much connected or not connected at all, actually, on a vulnerability parameter that is low parameter, safety parameter, and now we have in the new generation we have an OT and a connected layer that is IT, and sometimes we even have IoT on some detectors. So this provides an extra complexity which forces us to get to evolve this monitoring system that we've historically in our weapon system, and especially in the transition system between the transition time between the old and new system. To ensure the difficulty we have today is to integrate in supervisions, in SOCs, which we call hybrid SOCs, to integrate in supervision systems that have a fairly long implementation time, but coupled with IT of the latest generation. I'll speak a little bit more later about the implementation details. Okay, in complement, maybe we should also discuss about what is the utility in the end of the detection capacity and reaction capacities in an industrial context. In the IT, there's no discussion. Of course, We need to develop a detection capacity in order to reduce the surface of attack and the time to react. But in the industrial environment, we bring in new limitations because the detection and the reaction time becomes in a certain way the end solution, the final solution for legacy systems, which we don't know how to modify, which we don't know how to get to evolve, because we're in a system where we're still a Windows XP, VAX, VMS system, so we still have monitoring to do. This becomes the final weapon in order to detect a malignant activity on an industrial network. That's the first thing. But we also spoke earlier about military vessels that go on a mission. It's the same in a production unit. The windows of maintenance, the windows of change, they can't go on a very long period. So on this period where we can't modify a system because it's in production or it's on the battlefield, then we need to have capacities of detection and reaction. Just as a compensatory manner for these type of changes. It's important to keep this in mind. I mean, I'm quite voluntarily talking here about the detection and reaction because we're talking about industrial systems. In France, where we look at the industrial industry, we have 250,000, and not everyone is able to pay for an SOC. Those who are able, there was 100 out of the 250,000, the top companies, they are able to pay for a SOC, but most of them cannot invest in an SOC. For some of them, they can't even pay for an RSSI. So there's a real topic here on the industrial landscape and how they're going to develop the reaction capacities. And this is maybe where we should speak about the SOC, but maybe also detection reaction in order to integrate these industrial actors who are not regulated or who are not in the top range of the companies who have the means to do that. And I would like to add some elements to that. You need to be aware that if we look at duplicating in terms of supervision of what we have on IT for OT, it's not possible. You cannot supervise nor protect in the same way on OT as in IT. So we need to find ways, complementary ways, to have a minimum of control on the activity, on the industrial activity. Some figures here we need to be aware when we look at globally at all what happened in the year 2021. We had more than 50% of the industrial attacks that were linked not to vulnerabilities, to configuration defaults. That means that today we have a complexity of industrial systems. There's not many skills on the market. When you look people who have cyber capacities in France, it's not that many. We're all lacking in OT, even less. So this is a complexity that we need to master. Today we have systems that are deployed in the field, and I have them on the battlefield, legacy systems and new systems being deployed at the moment, and we have we lack a gap in capacities and skills. This lack in skills means that we have less control. That's quite simple. And in certain ways, a lack of technical mastery of the solutions and of the configuration. And when we see that half of the attacks are linked to configuration mistakes, it can either default or badly parameter security plans. We are very far from the vulnerability that we have been able to see at the FIC that is exploited by an assailant. It's really fairly basic attacks, which means that it's not necessarily technical issues that need to be taken into account to supervise an industrial system. It's also issues of methodology, of skills, of knowledge around the industrial environment. You mentioned the two parameters, the existing and the new parameters, the legacy and the new parameters. In the new parameter, you can imagine that the security is implemented by design from the upstream, from the beginning of the project. On the legacy, today, how can we integrate the existing in the legacy system in the protection parameter? Should we use existing systems that already exist in the IT, or more technical ones, or more procedures, technologies, or do we need to invent or find something specifically for OT? On this parameter, I like the next slide. I don't know if you can see it. Here we have I liked using Purdue as a methodological foundation to discuss on the industrial part. Many industrial systems, what we imagine is that we are immediately on the ground in the production tools, but you need to know that if you can see what I would like to illustrate here. You see the level 1, the main level 1, and level 2. Level 2 is everything automate, RTU, and the level 1 is really the field systems and the safety aspects. But in the end, all these systems today, when we arrive on Industry 2.0 environment, we have more and more IT components, which I call in my vocabulary the industrial IT. We have computers, servers, we have storage, we have virtualization, we have tablets, we have many interfaces that are IT noted, and these systems, we can already integrate them in the existing IT supervision, and just by integrating the IT supervision, we already managed to action all the supervision mechanisms have been developed for the IT and adapted to the OT world. We are going to find we'll have the Windows logs, we're going to have activity logs, we'll be able to correlate the SIMs. Yes, these are systems that are not necessarily in directory activity, but today at Microsoft, we have a Windows event forward. You can configure locally the environments Windows towards a collector, and this collector will then be able to connect to the cyber SOC to implement the enclave. So we'll have the standard cyber SOCs playbooks that are without having to invest much effort in order to achieve this. Of course, there's the connectivity part, but that's another thing. So that's the first thing. So we're going to do some supervision in the industrial world. We can already start with the industrial IT aspect. Then comes the application layer, the DCS and the CADA, the CADA. On the IT, since I haven't seen many trade SOCs that supervise trade events, I don't see many available on the market. I don't know what we could do better in the industrial level, but the good news is that today the systems that are in place for many years, so we have time to work on the application layer and integrate it in the supervision part. This is the first step towards the integration to the industrial part in the cyber SOC at not too much cost. And then there's the other complement, all the other things. That's where the new technologies with detectors, with intrusion detectors, this is where we'll have the complementary systems with the solid complementary solutions. There we will have the capacity of determining, or even with the log inventories, with and also detect abnormalities in the flows, detecting abnormal configuration events, and all this, bring it up back in the SOC, and everything linked to the playbook, the process, and people will more focus on that behavioral aspect of the industrial system more than the rest, because the rest is supposed to be already been handled by the IT teams. Regarding the data that is being collected by the SOC on an IT layer, an SOC IT, we will focus on data leak scenario, penetration, intrusion. In an OT SOC, the priorities are different from in OT. On an OT network, we're going to privilege safety and the availability of the network. So how does this paradigm, this change in priorities, influence the detection of the SOC? Well, the priorities are different between the IT and OT. IT is more focused on trust, on data protection, on data integrity. Well, OT is business, is running the computer. The machine needs to keep running. It's not the availability of the machine and its functioning, it's king with us, and cybersecurity is not even being if not even integrated in many industrial systems. If I go back to the lost architecture, like Mr. Miss has just said, between the levels 3 and level 5, there's a huge gap, and this gap, it's the DMZ zone. This is an area where IT and OT converge, and this convergence opens the doors, opens the surface for attack, because the new modern attacks, they are far more sophisticated. They're far more sophisticated and far more modern, far more industrialized. So the APT groups to sabotage a machine, they come in via IT to attack the IT, they come in via the OT. So this convergence exists now, and it's a good opportunity, competitive and commercial advantage in terms of Industry 4.0. We sell more, but it leaves the door open to attacks, to modern and sophisticated attacks. Yes, and I would like to add some elements to this. I think you need to start from the threat. What is the aim of the assailant upstream? You need to analyze each situation upstream. What happens today in the field of OT? The aim of the assailant is to block productivity. If he blocks productivity, he can raise a ransom, because of course a company that is stopped and the assailant can then claim a ransom. I mean, in 2021, then was probably 90% of attacks on OT, it's usually ransomware. The idea is to block the productivity and claim a ransom. Once we say this, in order to ask the question of the journalization of the logs, for instance, we need to take into account the fact that on IT, we know the supervision, we keep logs, we journalize, there's syslogs, etc. But on the industrial machines, there are many things that are not being logged, not being journaled. We don't know what happens in terms of behavior. So if we want to ensure a kind of a supervision, we need to find another way of logging the activity to ensure that there's normal or abnormal behavior. So in this here, we imagine, just a quick experience feedback, we need to work differently in IT and have an 4-pillar action plan. The first thing is to identify the protocols. We have the protocol in terms of operation that are particular. We have specific protocols which you can find in the army, which will not find in any other civil system, on the weapon system, on helicopters, on planes, where we what are the communication systems that we have on the system. The second thing is to identify the assets. When you have an helicopter, for instance, it has components. You need to identify the assets. On a helicopter, it's fairly well mapped. We know exactly what's inside, but in some factories in the industrial world, I know the industry well from my previous work life. We've invested since 40 years on robots, on automatization in the plants. Nothing was ever decommissioned. We've never taken anything. We've just added new layers. So 40 years later, we have legacy systems in terms of applications that are badly mastered, badly mapped. And today there are estimations saying that 50% of the assets in the industrial environments are unknown. So we've forgotten about them. They've been installed a couple of years ago. We don't even know where they are and what they're doing. So I think the second stage, there is a challenge of mapping these assets and to identify the sleeping assets, those that have been deployed a long time ago and which we have forgotten or we have not identified in terms of MCS or updates, etc. Once we've done these two stages, as my colleague was saying, it's to identify who communicates with whom, asset A with asset B on this protocol. And once we manage to do this, well, the first stage is to identify behavioral patterns, normal or abnormal. And when we manage, and here again, it's a sharing of experience. Once we manage to do this, we already have a first level of supervision of the industrial domain. And once we do this, At no stage we do not any requests to the system to generate logs or journals. I only work with protocols, the knowledge of my pool and who communicates with whom. And this already gives the first level, which is a fairly safe, good level of safety. And I would like to add a second point, which we mentioned earlier. We have worked, I don't know if some of you, Ministry of the Defense have worked for past years with the 8 major stakeholders in the defense industry on a convention in order to increase the maturity level of the supply chain and to help the big suppliers of the major players. We have done a roadmap and an action plan. We have identified in this action plan an issue which is fairly basic, that is the technical breakdown. You have a factory or a weapon system, it's the same. So you have breakdowns. The robot on the production line that produces the next Renault car was going to have a breakdown. So what do? We take the box, we change the part, and the production chain starts up again. And we realize that these cycles of industrial maintenance, traditional industrial maintenance, for most of them do not integrate an analysis of the technical events, looked at it from the cyber angle. You have maintenance operators who take take the component out, throw it away and put a new one in and don't analyze what happens. So what we're trying to do is to integrate systematically with the system operators a cycle to analyze in a mandatory way each technical breakdown from the cyber angle. Why? Because you could say maybe the component that was in the tank or in the Griffin in operation, he broke down. Why did it break down? Was there an electrical breakdown, or was there an injection in the maintenance phase via USB stick? So we're trying to understand from 2 points of view. You have the supervision and maintenance as I describe it, which is parametric, and also the systematic analysis of the technical events to ensure that the breakdown was not linked to an intrusion or a cyber event. In my perimeter, I'm absolutely certain that there are potentially factories that have underwent a ransomware, and since their mindset is availability, they might have even rebuilt the system without we, the cybersecurity team, even be informed about it. I'm absolutely convinced about that, because that's their mindset. They built around the problem. There's an issue of the technology. We also need to take into account the people aspect. But there's 2 points I wanted to take into account. On the convergence, you know that I hate the convergence. I do not like the idea of convergence ITOT. But to come back on industrial system needs to be available and produce. It also produces at the quality level as expected. This is integrity in the factory. When they understand what integrity means, you need to talk about quality, and on availability mainly. We know the supervisor. On the integrity, on the quality aspect for an SOC in terms of supervision is to be able to detect any changes today, to try to correlate these changes with the context of the source of the change. The program of a robot was changed today, but done remotely, with captors that industrial detectors that are able to detect changes in programs, and there's other systems when they do backups of robot programs. They can. It's kind of the industrial GitHub. They can between two backups to send an alert. This program has changed, and it gives you the number of the lines of codes where the change was detected. That's allowed. This is exactly how we can, for instance, fight something like Stuxnet. But once we have this information, we can contextualize. We can say, okay, there's been a change. Has it been planified? Is it something that it's been is it legitimate, or is it comes from the third party that it's not validated? And this is where we enter in how we integrate this in the maintenance interfaces, because we're talking about the limitations of a SOC about the industrial complex. We need to integrate also in the correlation everything that's the maintenance logic, maintenance times on the systems to say, okay, the guy in the factory, he's planified a change operation from this time, from 5 to 7 on this. So all the alerts coming back saying there's been a change of program. It's not really an alert because it's normal maintenance, because the aim is also in the limitations. It's important. We hear a lot of super experts and consultants specialized in OT saying, yes, you need an SSI correspondent in the factory. Great. SSI correspondent, that does not mean anything. For me, people in the factories, they're not here to do SSI. It's not their job. And a correspondent, that means he's going to have, if it's not in his job description, if it's not in his contract, it automatically means that the thing will be ignored. So the problem that is going to come out is in the SSI. The SOC is going to drown people. And the poor SSI correspondent is going to be completely swamped. And do you know what a computer is? Okay, you're going to be the SSI correspondent. So we need to far more reorient the SOC part and the reactive part towards what I call the knowledge people who can answer a simple question: what is this equipment, what was done on it, and was it being used for? And then we use the playbook. That's what the kind of skills you need. The aim here is we detect quickly the changes. We're able to quickly ask the right question to the right person. Is this change normal or legitimate or not? And based on the answer, we say there's been an incident or not. These are limitations which you need to understand and which we don't have in the IT world. This is the specific part that we have in the industrial world in order to manage the integrity part. In the HS part, you have the supervision aspect as in trade terms. This is where you need to start looking at the events that are generated by components, by industrial components that steer a mixing unit of chemical products. And this is where today the producers, the manufacturers, they have a role to play, and they need to produce these smart systems. They need to provide solutions that can be supervised. Early on, I was with a manufacturer. They have a service division that never speaks with the production division. So it's the same producer. I have two different partners. No, you are a manufacturer. You need to give me a solution, safe solutions that you sell to us. And then we'll talk about, there's a true topic of how the producers, the manufacturers what is their role in the supervision and reaction part. On this point, to give a small feedback on experience on our side, we are not too worried on the new systems that will be delivered. We work with the industrial partners. We have defined a rule book. We have clearly defined what we're expecting in terms of delivery. It's a journalization, logs. I'm not too worried on the new systems. I'm far more worried about the legacy systems that are still lying around everywhere. In the industrial works, we have very, very long development cycles, and there are things that are sitting around when they've been in operation for the past 30, 40 years, and they will still be there in the past 30 years, and that's what worries me. What we are trying to focus on at the moment is to try and find a way to ensure minimum of control of operations. I'm kind of repeat myself here on how we can IT, OT, and IoT interconnected, and it's going to put us back a couple of years back. For the future, I think we haven't been too bad in managing that. We've worked with the industrial partners, and it should work out. My worrying is really with the existing legacy installed pool at the moment. This is what's good when you work for the Ministry of Defense. You have the money to do that. No, I'm just joking, but no, it's not the case for everyone. But what I wanted to say in the introduction, I didn't want to be sarcastic. It's just that everyone does not have the same weight when talking to the manufacturers. I mean, at Iris, we are only 240 production units around the world. for a manufacturer, they ignore us. They say you're too small for us, so that our opinion doesn't matter. When the manufacturer, supplier of supervision tools, saying from now on you will not install any DR or you lose the support on your solutions, and we're alone. And they do it with all of them. Of course, we also need to play a part, our SSI, with the manufacturer. We need to push and the solution providers, but that is also a topic we need to take into account. It's only about 100 companies in France that are able to have an SSI system in order to ensure that the minimum conditions are met for the new systems. I just want things like when I change the password on a computer, on a robot, I don't need to restart the robot. That's really basic things. That's slowly coming, but still it comes in the new robots. But in order to achieve this, we had to discuss for a very long time, and there is a certain lethargy of the organization. And I forgot also to talk about convergence. I think that cyber does not have any role to play in the SSI security. For this, I have two arguments. The first one is that when you need to safeguard a system, be it converged or not, that is the first thing. So for me, when I say I don't believe in convergence, it's maybe too exaggerated, but I don't believe in it because there is no debate. For me, being it converged or not, I need to safeguard the system. And the convergence IT, OT, it's not a technology issue. It's a process and people issue. It means that in the end, is IT going to manage the industrial IT? Can I transfer the responsibilities? This is only people, processes and people. And from the industrial part, the guys, they lose control over the system. They say, if I lose the control over systems, I will not be able to maintain the operational condition and the availability of a system. So as a cyber person in charge of cyber integrate in this debate, it's senseless because I have seen it in the field. You can become, the cyber can also then be used by one of the other parties in order to retain its little power over the system. I don't want to go into that debate. You are converged, I safeguard. We integrate you in the SOC with new converged processes. If you're not converged, we'll deal with it and we'll integrate and we'll save you and integrate in the SOC. So I'm fairly on the convergence part. It's not a term I like.
Juste pour votre info.
For your information, and I'm sure you already have this information, but ISA, the Information System Automation from the US, just launched a white paper, and they also believe in convergence. No, it's their right, of course, they're entitled to believe in that. No, I'm not saying that convergence does not exist. I'm simply saying that cyber issues should not be included in the debate around convergence. Yes, that's true. Anyhow, convergence is the title of our roundtable. It's a challenge. However, I must say that I agree with what you said about people. Because in cybersecurity, from the feedback we had from our company in Germany, we have a cybersecurity culture that is integrated in our companies. And I'd like to agree with Mr. Blon, who really highlighted a very important point in the German automotive industry. This is something that we experience with our partners on a day-to-day basis with processes. Now, people are asking for the plan on the continuity of business, the PCA, and this is the priority. Don't tell me about risk assessment, vulnerability. They're simply going to focus on the plan, on the PCA, on their proposal. I signed specifications with 4 or 5 countries, and if I don't do that, I'll have to pay a fine up to millions of euros. So what you said is very important when it comes to the process. And when it comes to this plan for the continuity of business. And this is a key success factor in relation to the risk assessment, which is at the heart of cybersecurity and a good starting point in the OT part and for the industry. But I would say that the challenge here is that we need to work on an alert process, an alert plan, and we have to define an efficient warning plan. And then we need to check whether it is working. We need to supervise it on a permanent basis, and this will help the cyber defense security unit, and this is going to help also the crisis management department. All right, thank you very much. Now, today, if you look at the way an SOC is working, we're mainly talking about human skills, of course, but we will also look at processes, documents, etc. Do you believe that these are things that we can use again as such to apply that to the OT world, or should we invent new things or change the existing elements to adapt them to the OT? And do we need an SOC to supervise the IT and the OT? How should it be done? Well, I believe that we need to understand that SOC teams cannot do everything. The SOC teams are limited to a certain action perimeter. They have processes, they have manuals, and they can supervise IT, OT, or something else tomorrow. It doesn't matter. Everything is organized. They all have their own mission. But I believe we should not mix up the expectations for an SOC and what is the core business, because the SOC has a mission, and to develop that mission, they need a contact point with the structure they have to supervise. So for IT or OT, it's exactly the same. The SOC will detect abnormal behaviors. They will raise the alarm. I believe that everyone knows about this terminology. And then they have to assess the incidents, but they are not the only ones to have the answer. And I believe that they have their own processes. And to assess the incident, they need information from different trades and businesses. And they cannot do everything. They need to turn to people who are experts in supervision. And we made a distinction between those two variables, between those missions. But when we start the supervision of a system, we have people who are dedicated. And it's not always the cybersecurity manager. It's simply the guy who knows the system and to whom we can ask questions to wonder whether something is normal or not. This is how we're organized. Yes, I would even go further than this. And this is something that we do in the IT world, but it can also work in certain circumstances. I believe it is important to establish a difference between the detection and the reaction activities. The SOC is there to detect any problems, to give elements about the context, the background. And that's very important because, of course, it's going to enrich the event. Especially with the tools we have, with the automation. Sometimes you can detect a sword, but then if you have an updated directory with a rich content, you can know its location in the plant, its function, are there people who are remotely connected to the equipment, etc. That's very important. Now, I'm not saying that this is where I am. Of course, this is the ideal situation, but I would like to think about the future, and I believe that we need to have this rich list, and that's why I do not like using these terms, but I believe that it is important to have a rich inventory, good knowledge about the equipment. We need to be able to detect the event, to enrich it, to place it in its context, and then to put it forward to the reaction team that needs to be made by experts. Now, I'm not talking about a dedicated team, because we have those teams with people who are clearly identified in different businesses, and but I believe that we really need to have this reaction team, this response team that would be able to understand the context and the situation, because of course the challenge would be to inform the plant as soon as possible to trigger the right response. But the main reaction we have for the moment, because we do not have the tools that are available, for example, and this is something I'm fighting for the moment. So the only element that we have at our disposal is isolation. We can isolate the equipment, put it aside and try to understand what is happening. Now, this requires something else, and that's another constraint from the SOC that we need to understand. What is the consequence when you isolate a plant, for example? Because I believe that the plant should be able to work in full autonomy if it's isolated. Now, of course, some people will tell me if you stop the cloud, the plant cannot go working, but I believe it is important to guarantee this autonomy. We can isolate plants that are compromised, but also isolate plants to make sure that they do not become compromised. So we need to know what are the consequences of these reactions decisions on a plant. If you decide to isolate a plant, will it be able to go on working? And this is something that we really need to understand at the level of the team. Now, should we develop that on the side of the response and reaction team or on the side of the detection team? And this is something that should be decided by each company. Yes, I'd like to come back to the reaction or response. You said that the first mission of the SOC was detection. And in classical traditional SOCs, we have clear procedures. If you detect this type of event, this type of alert, the response is this one or that one. And there is a team in charge of the network that you can turn to, but it's more complicated for the OT, because if you have profiles of people who are involved in the SOC but who have traditional skills, they will not have the specific information and knowledge you mentioned about the trade or the business, and they will have to turn to another person, that third party. Now, if that third party works for production and receives that phone call saying there is an incident, you should do something, how could he or she respond and react? Will there be a transfer of knowledge? Will there be awareness training or courses so that teams at all levels are aware of this problem and this challenge? Well, I'd like to come back to this cybersecurity culture within corporations. It's very important to include that in the corporate culture. We need to promote an OT environment. You should have cybersecurity training courses. And it's true that for the SOC, OT, and analysts, that's more difficult to find that. That was related to your question. Yes, indeed, that was my question. And that's a challenge, indeed. But then you were talking about this third party, and we also always made recommendations to our partners saying that they should cover two important elements. First, a warning system with a system triggering tickets, notifications to open up the firewall and to require someone to work on the equipment and to close it after the activity. And this facilitates the detection part of things. Then if there is one element on the SOC, but if there is no ticket, there are two options. It could be an attack, a physical attack or a remote attack, or it could be something that someone forgot about. Second recommendation, never let someone from the outside of the company on his own without being accompanied by someone who's an expert in the equipment or the machine. Because you really need to have all the know-how, all the knowledge about cybersecurity. And if you are an expert in cybersecurity, you cannot be an expert when it comes to the equipment. Yes, I'd like to come back to the activity continuation plan or the business continuity plan. because I believe that indeed SOC can work on detection. Then you have a trade contact person to identify the problem. But then there's another stakeholder, and that's the industrialist. I believe that you should include that in your contract. There should be clauses identifying that cybersecurity is a performance and not a constraint. It should be considered as a performance as any other business or activity. This is what we do in our contracts. And the basic question is, am I going to promote cybersecurity on my 8 boats, or am I going to buy a 9th boat with the money I was supposed to invest in cybersecurity? So in your maintenance contract, you should include specific clauses to manage incident response. So if you have an incident on a system, you should carry out the expertise, you should turn to an expert, you should have the right technicians available. And this is something that is seldomly included in the contracts for industrial systems. And that's a real challenge. We really need to consider cybersecurity as a performance, and these clauses should be included in contracts to be able to face incident management. Yes, to come back to this incident response, are we going to ask the opinion of the guy working on the production line? Well, I believe that would be very complicated. Now, the guy in charge of computer security is just expecting the ticket, waiting for the ticket. He's not in front of the equipment or the machine. So the first thing to do is to isolate the equipment and then try to understand what is happening. Of course, the communication process is very important. And we do not work on incidents internally, but I regularly decide to stop relations with partners who have been compromised, and we just stop the whole groups, all the contacts with that group. But then you need to explain why you do that, and then you need to know the people well enough. Now, maybe this does not answer your question, but I believe it is important to have OT experts who know the industrial life of the company. That's very important, especially for the SOC cyber team. They could be on level 3, for example. So you need people who are dedicated to OT, people who have the knowledge, who know who to turn to, because sometimes it's quite difficult to know people in the IT team, and so you cannot ask them to turn to the OT team. So you need to have people at the SOC level who have the right knowledge, and they need to make sure they send the request to the right partner. That's very important. Thank you. We talked about challenges about the SOC in the industrial environment, and to conclude, if we look at the advantages of an industrial SOC, I would say that we have the SOC vision on cybersecurity, but we can also have a business point of view. This is something we discussed at the beginning of the roundtable. And don't you think that this could be an advantage? Something that could be used to sell the SOC and to enable its development and its deployment in the long term. If the SOC is able to detect availability problems very quickly and to detect the abnormal events on the production line, I believe that the SOC will improve the availability, and this will guarantee a better operation of the industrial tool, right? Well, I'm not sure I fully share that view. I do not know whether it is up to the SOC to make a judgment about the availability of a system. The SOC will detect events and assess the events, but the SOC is not going to determine the operational impact. Well, of course, this is what I experience in the Ministry of the Armies, but we have the detection stage, the assessment stage, and we simply see that there is an incident, and the person who makes the decision about the continuation of the operation is the military. And so we analyze the operational impact, and that person will determine the consequences. So the SOC will draw a list of all the equipment, but then it will be up to the commander to make a decision to stop or to go on with the activities. And I believe that it's not the same. The operational impact will not be determined by the SOC. Yes, I fully agree with you. And then sometimes we see that the business delegated that decision to the SOC, but that's a choice to have this delegation with some conditions. But then the owner of this decision and the decision-making process was defined by the business. So as a general rule, I usually say that I do not manage the D from the DTC. We manage traceability, we look at the manufacturing aspects, but we do not really manage availability because this is a business issue. It will be up to the business to make a decision. And I can give you an example. If you analyze the risks for a project, the first person to give a view about availability will be the business partner. So this is a trade issue. Yes, but that's a luxury if you can make that decision, because in Germany, the SOC managers sometimes have problems because of all the red tape, all the contracts, all the clauses. This reminds me of France. No, but I can tell you that in Germany, it's much worse. So as Mr. Blanc said, they make recommendations, but I can see that this is sometimes wasting time. And I fully agree with what you said, because you can waste 20, 30 minutes simply because you need to inform the business level. Are we entitled to make a decision or not? You know, in Germany, everything has to go through a written procedure. So you need to have written documents to support the decision-making process. Yes, and then you also have crisis drills or exercises, and that's the only way to make sure that people are well aware of the decisions to be made. And I believe that these exercises, these drills, can really help you to make the right decisions fast. Yes, about the decision-making process. In the Ministry of the Armies, we're also concerned by the kinetic risks, because, of course, there could be an impact on human lives. And here again, the decision-making process is shared, and we need a trust relationship with industrialists, because if you detect an event with a weapon system, for example, you need to go fast. If you are in the middle of an operation, you need to know whether you will continue or stop and go backwards. And I believe that it is essential to have this link with the industry, because sometimes we haven't planned everything, even in crisis management. You know, we all help one another, but then in your day-to-day life, you have to make fast decisions. So this relationship between the customer and the industry is very important. It should be based on trust. This is really important to manage this type of crisis. Yes, this is what I would call the capacities to anticipate, to know how the event will be processed. Yes, it's the right starting point, right? No, but the starting point is the incident or the ticket. But, you know, it's really easy to trigger a ticket, to open a ticket, but then what should you do next? That's where things become more complicated. So what will happen after the ticket is there, and what will happen between the time where the incident has been reported and the time where you actually identify the root cause and process the root cause, because that's the most important part, of course. Yes, to sum up your different comments. Ooh, that's going to be difficult. An SOC analyst who wants to intervene on an equipment has to be surrounded by people who know about the business and suppliers. That's really important in order to make the right assessments and make the right decisions. And today we have SOC teams working with IT teams, but they're sometimes a little bit isolated. Yes, but this needs to be done upstream. All these processes should be clear and in writing. I believe it's really important to identify that upstream so that you're ready when the incident happens. And then you can have dedicated teams or external teams on CSIRT. You really have to think about the competences, the processes of these teams, and you have to check the website of the FIRST. They're really a global stakeholder in this field, and they give recommendations with centralized models. And this is how I'm trying to explain this. What is important in SOC is not only the detection, but also the response and the reaction. All right, thank you very much. I would like to thank all of you. And I would like to open up the debate now to the audience. Are there any other questions or comments? No questions? Everything was clear? But with a microphone, please. Apparently you talked about 5 stages? No, I meant 4 stages only, 4 steps. Sorry, but I simply wanted to share our experience, and I'm sorry because I'm going to repeat what I said before. But what is important to me is not what will happen for the next purchasing operations, because I believe that will be quite good. We have reached the right level of maturity. But the most important question is to know what will happen in the next 30 to 40 years. And the problem as such is not about the tool or the equipment, because attackers who attack today were not born when our current systems were designed. So they don't know about our systems. And of course, they will not attack systems that they do not know about. So of course they're going to turn to connected IT, the OT, the IT directory, or something else. And I'm sure that you're all aware of the conflict in Ukraine. We had codes and sources that were delivered, and we had the malware, and the malware will stop actually if you have no domain controller, because if you have no domain controller, they cannot have access to higher privileges. So that's very important. You need to work on the ecosystem that surrounds the OT, focusing on the legacy tools. So you have to look at what is happening around the legacy. For example, the zero trust solution is something that should be developed further in order to limit the impact of the IT on the OT, because this could have an impact on the availability of a plant. These are the most topical issues. And then for tomorrow, I believe that we all have competent teams to define the constraints, and I believe things will be easier. But the main topic is to deal with what is happening today. Another question? But if there is no microphone, the interpreters can't hear you.
Ah ouais, alors vous l'avez, ils l'ont en fait. Ils l'ont, ça s'appelle une analyse de sûreté de fonctionnement. C'est juste... Donc,
so they have different methods. And I believe that here you're referring to the physical world. But here what is interesting is that you'll have the list of OT incidents in relation to the plant. You'll have, I don't know, the chemicals that can be found in the water. You'll have information about the incident. But then, how can you take these physical events and put them in relation with the production equipment? Actually, you have that information, but you need to find the right person, the person who was responsible for the security analysis.
Un événement physique. En fait, là, on va sur un sujet.
A physical event, that's what you mentioned. If you have to stop the production, you'll have financial loss. But it's very easy to find the guy who's responsible for the insurance contract. You can turn to him and ask him what will be the losses, what will be the damage insurance. And that guy will give you the value of the loss over a period of 12 months, because this insurance will consider that you lose the plant, so they're going to pay back what you lost. You can then calculate the operation loss over 1 month. So you have the financial aspects, then you have the images, and then you have the OHS, so occupational health and safety issues, and you'll have to turn to the people who are responsible for health and safety in your company. And they will give you the impact on the plant, on the environment, and on the resources. And that's how you can include that in your risk analysis. I hope this answers your question.
Alors, je fais un petit aparté au Césin, parce que je suis membre du Césin.
I'm a member of the CESIN, and we're going to launch a publication to explain how we can develop a risk analysis on a plant over a period of 3 hours only. Yes, I'd like to add on to this. You have the risk analysis, of course, but this risk analysis should be related to the compliance plan. You know, the risk assessment should not be developed in a one-shot operation. It's really important to detect potential threats. And when it comes to the supervision for the OT, I believe it's important to know, to have knowledge. You know, supervising an industrial tool is not the same as supervising a server. Then you need to work on security. You need to have default passwords. I told you about configuration mistakes. We need to know who communicates with whom, etc. Then the zero trust. And if you can do that properly, then I think you're on the right track. And you can manage the legacy I mentioned before. I believe that these are the 3 important elements you should put in place. Yes, I mentioned this last year during my intervention. I think it's important to start with a firewall if you want to secure a plant. That's very technical, but the firewall is going to help you because you're going to work on the security rules of the firewall. You're going to wonder about the assets that want to communicate with others, so you're going to try and understand the visibility. Then you're going to start the supervision with flow rules that will be clearly determined. And we didn't really mention that, but you should not forget about the remote access by third parties. So normally, you should really define the firewall, and then you're going to start discussing with the different trades to understand what are the possibilities of access for suppliers. It will enable you to initiate the debate. And then I'd like to come back to what I said before. The firewall is actually isolating the plant. If you do not have a firewall, then you shouldn't try and secure your plant, because that's the first thing, that's the first block. It's going to give you many advantages. And I believe that the first thing to do is to supervise the firewall and have this perimetric supervision in the plant. Well, thank you very much. I do not know whether there are any other questions. If it's not the case, then I would like to thank you very much. Well, I might add a few words just to summarize. In my view, IT should learn how to control or read, because of course machines and equipments do not speak, they do not talk, they are obsolete, they date back to more than 30 years, you have log issues. So you can have a variety of problems. So the IT should speak the OT language and the OT should speak the IT language to find a solution.
Très bien, eh ben, merci à vous.
All right, thank you very much. Have a very nice day.